Hello, I'm going to be doing problem number 5 from chapter 15 in the physics book. So it's a simple harmonic motion problem, and our first step is to find the position of the particle. So we're given this, and this is going to be kind of our goal statement. So x equals 2 centimeters, and that's going to be the amplitude. That's the amplitude sine of 3 pi t. So let's start with our general position function for a simple harmonic motion. So it's x equals a for amplitude cosine omega t plus phi. So there are quite a few things that are different between these two. So let's first start with the amplitude. It says that the amplitude is 2 centimeters. So x equals 2 centimeters cosine omega t plus phi. Then it says that it starts at the origin. So that's going to deal with our phi, which is our phase shift. So it's x equals 2 centimeters cosine omega t plus pi over 2, because that's going to be the middle at the origin, because when there is no phi, that's going to be on one end. So our phi is pi over 2. And then we see that here it's cosine, but there it's sine. And when you have cosine of something plus pi over 2, if you think about the way that the graphs are, that's a phase shift. So cosine of something plus pi over 2 is the same as sine of that same something. So we can just rewrite it as x equals 2 centimeters sine omega t. And then lastly, we're given the frequency. So we know that omega equals 2 pi frequency. That's 2 times pi times 1.5 hertz. So omega is going to be 3 pi. So x equals 2 centimeters sine 3 pi t. Okay, so we got part A done. Then next, we are going to be dealing with the velocity and the maximum speed. So speed is going to be the absolute value of the velocity. So we're going to take the derivative of this statement right there. So it's going to be v is equal to 2 centimeters times 3 pi, because chain rule from there, times cosine 3 pi t. So our velocity is going to be 6 pi cosine 3 pi times time. Now we're going to look for the maximum velocity. So in order to find the maximum velocity, we want to find the maximum of each of the different parts of this expression. So we want to find the maximum of this function. So the maximum of that is going to be 1, right? So then we want to find out when this is equal to 1. But since it's asking for the maximum speed, it could also be -1, because we're taking the absolute value. So 1 or -1. So this will equal 1 when its time is going to be 0, because cosine of 0 is 1. But the time has to be greater than 0. So then the next bet will be -1. So cosine, and then we know that cosine of pi equals -1. So you want to find cosine of pi is equal to cosine of 3 pi t. So our time is going to equal 1/3. And then at time equals 1/3, the absolute value of the velocity is going to equal 6 pi times the absolute value of -1. So that is going to be the maximum velocity. And excuse me, the maximum speed. Next, we're going to be finding the maximum acceleration. And it does not specify the magnitude of the acceleration, which means that we have to assume that it means positive. So A equals 6 pi, and then we're going to do chain rule again from up there, 6 pi times 3 pi, then sine 3 pi t, but then it's negative. So our acceleration equals negative 18 pi squared sine of 3 pi t. Then, so we want to find the maximum of each of the little parts. So we see that this is a negative number. Then in order to make this whole thing a large positive number, we want to find this at its minimum then. So we want to find that when that's negative 1. So we know that sine of 3 pi over 2 equals negative 1. So sine of 3 pi over 2 equals sine of 3 pi t. So we know that t equals 1/2 second. So that's going to be the time at which it's the maximum acceleration. And then once we put it in, so that's going to become negative 1. So the acceleration is going to equal negative 18 pi squared. Then lastly, for part D, when it asks us for the distance, the easiest way to find the distance is to use the integral of the absolute value of the velocity. So we know that the velocity is in terms of t because that's our variable. And if we just take the integral of velocity, that's going to be displacement. But since this is simple harmonic motion, it just keeps on going back and forth, back and forth, back and forth. So it's not going to be that much displacement, but there's going to be a lot of distance covered, just kind of like going back and forth. So we're going to use speed instead of velocity, because then whenever it's a negative velocity, it's not going to go backwards. Then we're integrating in terms of dt, and it asks us to go from 0 to 1, and that equals 12.0000367 centimeters, which equals 12 centimeters. Okay, thank you very much.